Welcome to How to Accelerate Python Code with CuPy GPU Power. Today, you'll learn how to unleash the potential of GPU acceleration in Python using CuPy, enhancing your data processing efficiency and computational performance. Did you know that using GPU acceleration can make your Python code run up to 100 times faster? Welcome to our deep dive into CuPy, the powerful library that brings GPU acceleration to your Python environment. In today's video, we'll explore how CuPy can transform your data processing tasks, especially if you're a data scientist or engineer aiming for optimal performance. We'll look at setting up CuPy, converting existing NumPy code, and benchmarking CPU versus GPU performance. By the end, you'll be equipped with skills to harness the power of GPUs in your Python projects. So, let's dive in and start accelerating.
CuPy is a powerful open-source library that extends Python's capabilities by allowing you to execute NumPy-like operations on NVIDIA GPUs. If you're familiar with NumPy, you'll find CuPy's syntax and functionality remarkably similar, making the transition quite seamless. The major advantage of CuPy lies in its ability to harness the parallel processing power of GPUs, which can dramatically speed up computation-heavy tasks such as matrix multiplications, convolutions, and more. CuPy is particularly advantageous in fields like deep learning, scientific computing, and big data analysis, where computational efficiency is paramount. In this section, we'll explore how CuPy integrates GPU functionality into your Python code, providing a robust alternative to traditional CPU-based processing.
To start using CuPy, you'll first need to ensure your system meets the necessary requirements, primarily an NVIDIA GPU with CUDA support. Begin by installing CUDA and verify that your GPU drivers are up to date. Next, you can install CuPy via pip using the command pip install CuPy, where 20 corresponds to your CUDA version. Once installed, verify the setup by running a simple CuPy command, like creating an array. If you encounter issues during installation, check compatibility between your CUDA version and CuPy. This setup process is straightforward, but ensuring each step is correctly followed will prepare your environment for leveraging CuPy's full potential. Transitioning from NumPy to CuPy is surprisingly straightforward due to CuPy's compatibility with NumPy's syntax. Begin by replacing NumPy imports with CuPy. For instance, converting a NumPy array to CuPy can be done using CuPy.array instead of NumPy.array. While most operations remain the same, it's crucial to understand that CuPy operations are executed on the GPU, which might necessitate adjustments in how you handle data transfer back to the CPU, if needed. We'll walk through practical examples, highlighting the subtle differences and showcasing how to efficiently convert your existing NumPy scripts into GPU-accelerated CuPy code, thereby enhancing performance.
Understanding the performance gains from using CuPy over traditional CPU computations is crucial. Benchmarking helps quantify these improvements. By comparing execution times of similar operations on CPU and GPU, you can observe significant speedups with CuPy, especially for large-scale data processing tasks. We'll use tools like time and CuPy.CUDA.profiler to measure execution times and analyze performance differences. This section will guide you through setting up benchmark tests, running them, and interpreting the results to understand how CuPy accelerates your Python code. This knowledge is invaluable in deciding when and how to effectively use GPU acceleration in your projects.
CuPy excels in executing array and matrix operations with high efficiency. Whether you're dealing with simple array manipulations or complex matrix algebra, CuPy offers a suite of built-in functions designed to maximize GPU performance. We'll explore how to create and manipulate arrays, perform matrix multiplications, and utilize advanced operations such as singular value decomposition and fast Fourier transforms. By leveraging these capabilities, you can achieve substantial performance improvements in data-heavy applications. Practical examples will demonstrate how to optimize your code, ensuring you make the most out of CuPy's powerful GPU-accelerated functionalities.
Simulations often require a large number of random numbers, and CuPy's GPU-accelerated random number generation can significantly speed up these tasks. CuPy provides a random module similar to NumPy's, allowing you to generate random numbers with enhanced performance. This is particularly beneficial in fields like Monte Carlo simulations and other stochastic processes where speed and efficiency are critical. We'll delve into how to use CuPy's random number generation capabilities, providing examples and best practices to ensure you can efficiently integrate this into your simulation workflows, optimizing both speed and performance. GPU programming introduces unique challenges, and debugging can often be a complex task. Common issues include memory errors, incorrect data types, and synchronization problems. CuPy provides detailed error messages and debugging tools to help identify and resolve these issues. We'll cover how to interpret CuPy's error messages, use tools like debuggers and profilers, and implement strategies to troubleshoot and fix common problems. Understanding these techniques is essential to ensure your CuPy code runs smoothly and efficiently, allowing you to fully leverage GPU acceleration without the frustration of persistent bugs. Maximizing GPU resource utilization is key to achieving optimal performance with CuPy. Effective memory management, minimizing data transfer between CPU and GPU, and leveraging parallel execution are crucial strategies. CuPy offers features like asynchronous execution and memory pooling to help optimize your code. We'll explore these features, providing tips and techniques to ensure you're getting the most out of your GPU. From performance tuning to optimizing data handling, these best practices will empower you to write highly efficient and effective GPU-accelerated Python code, making the most of CuPy's capabilities. We've covered a comprehensive guide on using CuPy to accelerate your Python code through GPU power. From setting up and converting NumPy code to benchmarking and debugging, you've gained valuable insights into maximizing computational efficiency. As you continue to experiment with these techniques, remember that GPU acceleration can revolutionize your data processing workflows. We'd love to hear your thoughts, so leave a comment, share your experiences, or suggest topics you'd like us to explore in future videos. Thank you for watching, and stay tuned for more exciting content on optimizing Python with cutting-edge technologies.